Hey everybody, this is Larry. This is day 5 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this prompt as soon as it loads, maybe. Today I didn't do that much. I kind of just rested. Another year, huh? 37 is today's prompt. Move pieces to obtain a string. Alright, so you get two strings, start and target. Each string consists of only the characters L, R, and underscore. Okay. The characters L and R represent pieces where a piece L can move to the left only if there is a blank space directly to the left, and a piece right can move right? Alright. And space is okay. So so you want to keep moving. Okay. This is annoying, but generally doable, right? I think the way you want to think about it, or I want to think about it, just almost like a simulation, right? You want to almost like gravity of sorts, right? Just throw them on, and then see if it is possible in a greedy kind of way. Yeah, and I think you can actually separate them out in the, I want to say, two places, because there is this idea, right, where it feels like if you remember calculus, almost the intermediate value theorem or something like this, where, well, if it's impossible for L to get to a space because an R is in the way, then there's no way to get there, right? Well, that's one, but also then it doesn't matter because then the R cannot go to its space anyway, right? So it almost doesn't matter whether there's no moving back and then the L goes over or something like this, right? So it allows us to kind of determine almost if you think about other things, like just what's it called? You can almost decompose a function, right? You have this thing, you have two things kind of doing at the same time, but you can actually just break them into two problems that are very similar, and that's really it. So yeah, so I think we can do it by I think the way that I want to do it is just maybe left, like a matrix for where the left stuff is and where the right stuff is, right? So for index, C in target, right, or in enumerate target, so we get the index. I don't know why I put this here, but yeah, and then now if target is equal to L, I've been trying to make more of an effort to use the switch syntax, which I think I still honestly probably get wrong, so we'll see. But yeah, target, we go to left. If it's left, then left dot append L. Oh no, index. What am I doing? Right? And then otherwise, yeah, I mean, I guess technically default, but maybe continue. It doesn't really matter. It doesn't do. I think we should just remove it, right? Yeah, right. And then we can just print it out just to kind of verify to ourselves that everything we're doing is Gucci, right? So it looks okay. Nope, that does not look okay. Oh, not match target. Whoops, match C. That's why. Okay, I mean, this is why you test. So yeah, so the left is 0 to 7, 8, and you're really good on index. And then now we can. There's probably a couple of ways you can think about this, but the way that I'm thinking about it now anyway, is yeah. How do I want to think about it? Yeah, so then now maybe because there are two ways to think about it, really, right? And I'm just going through it in my head, which is that one, you can enumerate on the target, or you can enumerate on the start, right? And I'm trying to do the pros and cons of which in my head, honestly, and I don't know. It does, maybe I'm going to do it on target, but maybe yeah, maybe it just becomes maybe I'll regret it is one thing, I suppose, but I don't know. So this is for each index in left, and then we want to do a two pointers algorithm on the other one, right? So then maybe like a S index for start index is equal to 0, and then now we want to match. Okay, so S index, because everything that we already passed. Just want to double check. Does it have to be exactly the target, or do they have the same? I guess it has to be exact. So then the first thing I would also double check is that if start.countL is not equal to target.countL, then we return false, and then do the same thing for all. You could probably put this in a loop if you like, I don't know, right? Because I think I don't have to explain this one, hopefully, right? If they don't have the same amount of things, they'll never match. So then, but the reason why we want to check this, and you don't have to, depending on how you implement it, but it allows me an invariant that I can keep track of, right? Which is that, okay, now we know that there's 1-to-1, so that means that we can keep looping until the end if we don't see one, right? So then S index is equal to max of S index, and then L index, yeah, right? Or S index plus 1, right? Because then we moved on. Or maybe not. Maybe we go increment later. So maybe this is fine. And this line, what it does is saying that, okay, if the current search index is before, then we want to move it to the target, because, I mean, you know, we just skip, because it doesn't matter what's in between, right? Because you have to get to the target. Otherwise, then now, well, we keep on going S index, going from left to right, because the left we can go, right? So then, so yeah, so then while S index is less than n, we have to set n is equal to negative start. While this is true, we n start of S index is not equal to L, then we just increment. But there's a little bit of nuance here, because there is a right? So yeah, so we increment, but actually if we go if start S index is equal to right specifically, then we just return false, because that means that we see a right. That means that it's going to always block everything to the left of it, but we still have the left, we still have to some on the target to match. So yeah. So then now the invariant here then now is that either S index is equal to n or start S index is equal to L, right? I mean, that's just basically the opposite of this, right? Or yeah, the opposite of this, really, right? Because that's the invariant, the loop invariant, if you will, right? And then now, yeah, we just have to check if S index is equal to n, then we ran out, so we return false because we never found it. Otherwise, then you can add in assert if you like. Sometimes I like to do that, and then S index increment by 1 because we consumed it, and that's pretty much it. So that's the left side. How you want to do the right side, we can also do maybe, right? Actually, let's kind of how do I want to? Maybe I could like generalize, right? So this is the solving the left side part, right? So we have all this stuff, and then maybe now you could, you know, do a thing of check, right? And what you want to check is, I guess target doesn't change. The thing is that change the character, and then the other character, I guess. I don't know. Naming is hard. Sorry. But yeah, and then now we can return true if all the conditions are true. And then now you just have to I used to say. So this is correct maybe, or I don't know, target maybe, but target is also already thing. So oh no, what are you doing, Larry? No, you. Yeah, so something like this, right? And then now you can write check of LR. Oh, I kind of messed up. Oh, this is fine, but I think that yeah, maybe we need start and target, right? So then we just check start target LR, right? So then here we want to return this. So it has to be that this is true and the opposite is true. So check of start target, kind of, we'll change it, but right? But except for that this is going in the opposite direction. So then there we just kind of reverse the string and we should be good. I hope. I mean, you know. Oh no. Well, I'm returning false by the way. Yeah. Anyway, that's the idea of how I would write this so that I don't copy and paste. Maybe copy and paste, but right, I don't know. But yeah. Do. I mean, we tested this. So it's returning false. Well, let's take a look at just the left part first, just to make sure that it's not dealing with that part. Nope, it's still just returning false, so that means something is really wrong with where am I returning false? Is it this? You can also write this another way with the spaces, I think, but Okay. I mean, that. Okay. Yeah, now I'm in debugging mode because I have no idea what's going on. But okay, so this is for case 3. So what's case 1? Case 1, why? Tell me why. So okay, so we do and check with that target. Okay. Oh, and why did we return false? So I guess that's why you don't do the reverse. And here we return false here, but I guess because that's the only other place. Left index is 0, so then 1, and then it should be returned true, right? What? Why? Start s index. Correct. Did I mess up with the correct? Did I huh? Why did it reach the NR and then correct is wrong? Did I mess something up? Why? What? I mean, that may explain why, but why did I have a typo somewhere? Did I do LR, right? LR? I mean, I probably shadowed this somewhere, but where? Alright, well. No, so it starts okay, but then it reaches the end and it... Did I assign correct somewhere? Case correct? No? I'm so confused. Is this a function that like I used by accident? I don't know. Oh, so then after here. Huh. I think there's something with case functions that I don't know about. Or like, yeah. Maybe the switch thing is wrong. Because it changes the value of correct as we see. And there may be some nuances that I don't know about. So, okay. So, growing pains, but also better to learn during a contest than here, I suppose. And I don't need a match statement anymore, anyway. Now that I kind of rewrote it. So, okay. So I don't know. I mean, I don't know why, but at least I'm learning something. So that's actually legitimately something I'm learning and not like a... It's still a silly mistake, but it's not a classic Larry silly mistake. You know, that's a very legitimate way of doing it. But yeah, basically the idea here is just 2 fingers on the left, and then on the right side, all you have to do is reverse it, right? It's symmetric. So you check the start, you check the target, and that's pretty much the idea. Let's give it a spin, and hopefully I didn't get a wrong answer. Last time I had 2 wrong answers, and this time I have at least 1 wrong answer. Why is that not right? I wrote true. Why? I wrote L. So L is the target input. But we start at... Yeah, if this is equal to... Oh, that is... That is nasty. I actually did miss this case. Because basically what I was only checking is that there's an R in the way between. So if I'm looking at here, let me actually put in the ASCII art a little bit. Okay, I mean this is, I don't know if it's a classic Larry silly mistake, but it's still a bad mistake. I just didn't consider this case. Where basically I'm going from here. I'm saying that this left has to go from here to here, and of course on the there's nothing in between. But I didn't combine. I guess I was wrong, honestly. I mean, I was right in that if there exists a case, this would what I said. So okay, let me step back for a second. Hang on. What happened is that what I said was true in the sense that nothing is in the middle, but the converse is not true. I think that's what happened. So yeah, I think that's what has happened. I mean, it should be an easy fix, but honestly, I don't know anymore. I don't know if this is sufficient. Like now, I have to kind of prove this, right? Or like I have to prove that this is sufficient. I mean, it obviously solves this case, but is there a way in which, like, maybe something like this, would that work? Like, is that a possible wrong answer? Let's see. Jeez. I guess I could just write it here. Looks okay. I just don't want to get two wrong answers. I probably made the same mistakes, honestly. I'll probably make the same mistake this time too. Oh no! Oh, Larry improves this one fewer mistake than last time. But yeah, I mean, I mean, in a way, these 2 pointers are always greedy in a way, right? So that's why it works. But also, it's because it's greedy. It's also why it doesn't work, right? That's why you have to kind of prove these things correct. Let's take a look at what past Larry did. I don't know why the loading is. Am I like on same input? Last time I got this input wrong. Oh, why are they 5 days apart? Huh. Like, what did I just forget to do these farm or something? I don't get it. But okay, so there's this big one. So there's no way for me to not no way, but I'm probably not going to dig into why this is. Okay, maybe we could just take a look. I wish there's like a diff function of like, okay, I wrote these two code. What is the difference, right? Okay, so the top is mostly the same. So starting from line 8. Well, I just made this into like n square ish. No, that's not true. It's just a different way of writing it. But I don't know. I mean, I'm too lazy to dig into like the past Larry and why it fails and all these things. But today I did a little bit better. But I don't know what is the difference. Just nothing in between. But I already do this kind. So I mean, I think one reason why I did this is because if we do this skip, which I did before, there's an R in between, right? But here but today I did the same thing, really. So like today I did the same thing without checking. So what is the difference here? I don't know. This one is too wonky for me. Okay. I mean, I don't know. Maybe I'll find out in 5 days that I need to do this again, apparently, or something. I don't know. Maybe they add more cases. I don't know what's going on anymore. I'm not very good at this today. But that's all I have for today. Let me know what you think. Thanks for watching. Hope you didn't make my silly mistakes. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.